everyone. So Cynthia, if you want to start, you have the floor. I don't know what it is, but you have the floor.
Thank you so much. And can you all hear me there? Good? Yeah, okay. So yeah, I think for the ones that don't know me, my name is Cynthia Obregon. And we're going to talk about, my presentation is about rare elements geochemistry in two former polymetallic mines from the Iberian Pyrite belt. Well, let me see. Okay, so this is the outlet of my presentation, and I'm going to talk about São Domingos and Lousao mine that you all had the opportunity to visit in the last couple of days in the field trip with EDM. So I'm going to show the preliminary results that we have, and I'm going to show some sampling points, chemical composition of the water, and some of the rare element patterns. And also I'm going to talk a little bit of the iron speciation in sediments. And yeah, I will finish with some final remarks and next steps that I'm working on. So as you know, the location, both mines are located in South Portugal, and they are part of the Iberian Pyrite belt. And they are polymetallic sulfate mines, and they are both mine legacy sites here in Portugal. So we have Lousao in the western part and São Domingos close to Spain. And so I'm going to start first with São Domingos. And here we have a plan view of the mine. And what is very interesting, and I think you saw, is that the mine residues from the mining activities are spread throughout the mine complex, and these are very highly heterogeneous. And at the time that we collected the samples, there was no treatment system ongoing in the area. So here we have 7 sampling points where we collected water and the sediments that were in contact with the water. And the objective is to see the distribution of the rare elements in acid mine drainage affected systems. So here we have. So here we have the chemical composition of the water that we collected, just the pH and the sulfate and iron concentration in the points. Just to mention, we have this one from Tapada Grande that is clear water, but that is here, this one here on top. And compared to the other ones, the pH overall is acidic, is less than 3 in the whole mine complex. And we have 2 values in some of the samples. The red ones, because we did 2 sampling campaigns, but part of the objective of my PhD is also to see the seasonal behavior. So in red, we have from the sample campaign in November, and in black from May of last year. So we can see overall, besides the Tapada Grande, we have acid pH. In November, we have from ranges between 2.37 to 2.86. And in May, it's between 214 and 238. So it's a little bit lower. So when we compare the sulfate and the iron concentration, we see that there is an increase, both the sulfate and the iron concentration from November to May in almost all the samples that we collected in the 2 campaigns. And we see that the sample with the lowest pH register and the highest sulfate and iron concentration is the one that we collected from the open pit lagoon that is here on top. I don't think you can see my mouse, right? I hope so. So regarding the rare earth element patterns in the water, and here we have the 3 samples that we could collect both in November and in May. So here on top, we have the patterns in November and here the patterns in May. We can see overall tendency to have an enrichment in the middle and heavy earth element in the water. And we can see that we have higher concentrations in May that it was what we expected. So regarding the other samples that we collected in May, the water samples, here we have also the patterns. The highest concentration is here, is from this one, that is from the open pit lagoon, but it also has the same with the other samples that we collected previously. They all have the same tendency to have an enrichment in middle rare elements in comparison, especially with the light rare elements. And I also wanted to show that something interesting happening with 3 samples here, that we can see that they all have a similar concentration and this same, almost the same tendency. There are these 3 samples here. We can see here in the graph that they were collected here, but the similarity that they have, they are from different sites, but they are all collected from the acidic streams that goes along the mine complex. And the other 3 are from the open pit lagoons and also acid lagoons in this area. So regarding sediments, here are the samples that we could collect that they have from the 2 seasons. And we can see that there are some changes in the patterns when we compare November and May, especially here the 06A5 that have a lower concentration and a different pattern exhibit in comparison to the ones in November. But overall, they seem to have, especially in November, enrichment in light rare elements in comparison to the heavy. Okay, so regarding the other samples that we collected in May from the open pit and the other lagoon, and here at the end of the acidic stream, we have that the sample from the open pit lagoon has is this one here, has an enrichment in middle rare elements in comparison to light rare elements. And also want to showcase this one here that is 03A1, that it has an interesting pattern, more distinctive comparison to the other ones. It has a enrichment of middle rare elements in comparison to both light and heavy rare elements. So when we see it here, this is the sample, 03A1, that is collected from this acidic lagoon here. So we have some small heaps in this area. So here on top, we have the pattern from the sediment, and down the water, we can see the enrichment in middle, not as, and then in the water, we see the enrichment in middle and heavy rare elements. So we see that the heavy are less incorporated in the sediment and they are more present in the water. And we think that's that because heavy tends to form more soluble complex, and this is a close, almost confined pond. So we have more water sediment interaction. So now I'm going to talk a little bit of low salt. Here we have a plan view of low salt. Here we have the 2 acidic points that you guys visit, and here we have the passive treatment system. I just want to show that this here is the Corona stream that goes close to this area. And here are sampling points. We collected some samples, some samples along the passive treatment, and also in the Corona stream. We collected same water, and the sediments were in contact with the water. We also collected some samples that I didn't show here, but water samples from the Corona stream previous to enter the mine area. I will show you later on. Yeah, the idea is also, the objective is to see the distribution of the rare elements in a passive treatment system. So here we have some parameters. Also, again, seasonal, to see also the seasonal behavior. We have November in red, and in blue, black, we have May. First, I'm going to talk here about the passive treatment system. Overall, the values are below 3 inside. So we have in November, they vary between 2.89 and 3.08 here until this area here. And in May, it changes from 2.31 to 5.16. So we have an increase of the pH in May. And regarding the sulfate and the iron concentration, as expected, we see it to go up for both comparison when we compare November to May. But with the exception also in this point LM07, where we can see that the iron concentration goes down. Here we have two samples that are 0, 9, and 10. They are points where we collected before and after the discharge of the passive treatment system. We can see that the pH is high comparison to what we have previously. And we can see that the sulfate concentration goes down when we compare November to May. And I will talk a little bit later about it. So regarding the rare element patterns, only for the passive treatment system, here we have for the water, different areas that we collected. And here in November, we can see the a tendency also an enrichment in middle rare elements, especially in comparison to light. We can see a little variation in the light rare earth elements in all the samples. But when we see in May, we still have the same tendency in most of the samples with the enrichment in middle rare earth elements. But this sample LM07, it has lower concentration and an enrichment more in light and medium comparison to heavy. So this is regarding the passive treatment system. For the corona stream, here we have the other points that we collected samples, 12 and 11, and that they are both before entering the mine complex. And when we see for November, we see here two like distinctive groups, the samples that we have for control of the area, and the samples here were before and after the discharge of the passive treatment system. We see that the highest is from LM10 after it received the discharge, but we also see that in point LM09, it's still higher in comparison to the other ones, and it has also a similar pattern. And in May, because there is less water flowing, almost no water flowing from the passive treatment system to the corona, we were expecting these values to go down, as we also saw with the sulfate and the iron concentration. And we saw it in this point in LM10, but LM9 is still is the highest with the highest concentration in comparison to the other ones. And this is due to the presence of an acidic discharge that we notice later on to the corona stream. The flow is not as much, but yeah, that would contribute to this pattern and the high concentration that we see, especially in this area. Regarding the sediments, the patterns are here. Here I included the sediment samples from the corona stream after the discharge of the passive treatment system, that is this one here. So we see that in November, they all seem to have a similar pattern and enrichment of light and mirror in comparison to heavy. Yeah, the highest being this one, LM03, with the higher concentration, that is from the acidic pond. and the lowest in the corona stream. But in May, we see also most of the sample preserve the same tendency, but with lower concentration, with an exception with the sample collected in the corona stream that increase the concentration, and it has an enrichment of the middle rare earth elements in comparison to light and heavy. So when we see this one, here we have some pictures in this point from the water that we saw in November and in May. And in November, the pH both is above 5. But in November, because there is more water flowing from the passive treatment system, this area is area of mixing water. So it increased the pH, but because we have a lot of particles in solution, we can see this whitish color. So that will affect the values that we have. In May, as you can see, we don't have this whitish creamy color, so we don't have that amount of particles in suspension. So we think that because of the changes in the dynamics and the flow system, that will increase the presence of these elements in the sediments. So concerning the iron speciation, and I'd like to present some of the results that we have, and with the major differences between São Domingos and Lousao. The technique that we use is most power spectroscopy that we couple with XRT. So here we have some examples of the spectra and the results that we get from the technique. We have one from São Domingos and one from Lousao. And we have different measurements at 3 different temperatures, and we can see the iron species and the mineral or mineral phases that are associated with, and we can calculate at the end the percentage that we have this in our samples. This is very, I'm talking in general, this is a lot going on in this, but yeah. And so I want to focus because also we can see the percentage of nano-sized oxides, and I wanted to present this one here just to show you a little bit. So here we have 2 charts of the percentage of nano-sized oxides, both in Lousao and São Domingos, and we can see that we have a high percentage of nano-sized oxides in both areas, and there are even some points that we have that 100% of nanosite oxide, so all the iron is present as nanocytes. We can see when we compare November and May that there is in most of the cases an increase of the percentage, and both in Lousao and in São Domingos overall. I want to do some remarks. From all the results that we got from Mosbauer, when we compare São Domingos and Lousao, we can say that the predominant species, iron species, is iron 3. And you can see it that's mostly as nanocytes and also in bigger particles. In both areas, we have high percentage of nanocytes oxides. And some of them in the table that we have, in the data that we have so far, these are mostly represented in hematite and ferrihydrite and goethite. I wanted to mention something interesting that we found from the results, that in both areas we have hematite, but in São Domingos, there are some points that we have pure hematite, so there are no impurities. So it's very low, the percentage, but it's just worth mentioning. And also we found jarosite in both areas, but it's more predominant in São Domingos in comparison to Lousao. And we can find it almost in all the sampling points. So it's more spread, but on the other hand, in Lousao, it's only found in 2 points. And yeah, so it's more local. So as final remarks, and as I mentioned, this is still the preliminary results, but we can say overall that, for example, the rare earth elements pattern for the water, it shows an enrichment in middle rare earth elements that that it has been reported by several authors in this type of acid mine drainage affected systems. And regarding sediments, we can see that there is a lot of variations between the two seasons. So it's not very clear, but we can see an enrichment overall in light and middle in comparison to heavy, especially in low salt. And regarding iron speciation, iron 3 is the predominant species, and we have a high percentage of nanosized oxides, and we have a jarosite in both areas, but it's more spread in higher quantities in Sao Dominguez in comparison to Losa. So this is, yeah, I mentioned a work in progress. We're still trying everything that we have, and we still have a lot of experiments and analysis to do. So yeah, if you have any questions, I will try my best to answer them. Thank you.
So I think you should hear me. Yes, you hear me, Cynthia?
Yes, I hear you.
Okay, perfect. So I don't know if we have any question in the crowd about the presentation. Yes, Nikit, you have one?
Wondering about the actual concentration of the element.
You couldn't hear that, Cynthia, did you?
No, not gonna.
So Mukit was saying that he was wondering about the actual concentration of rare earth elements.
Oh, in water, sediments.
Both.
Both.
Sorry.
I will have to give you that data later because I don't have it with me right now. I'm sorry.
Okay, maybe we have some other questions about it. No, you're good. You're all ready to go for lunch already.
Yeah, I believe.
Okay, well, thank you very much, Cynthia, for taking the time to do this presentation today. In any case, you're all ESR, so if you have questions later, don't hesitate to reach out to Cynthia. And yeah, I think we can call it a morning, not a day, because we meet again this afternoon. Just some information about this